Hello friends, in this video tutorial let us see a very important concept of SSAS MDX queries. So for this let us go to SQL Server Management Studio. Now over here we are connected to SSAS Dev3 database, and inside the Dev3 database there are two perspectives and one cube. So we are connected to the cube, main cube. Now there are two measure groups, one for internet sales and one for reseller sales, and we have got some calculated members of average sales, parent amount and total sales. Also we have multiple dimensions like dimension for currency, customer, employee, product, reseller, due date, order date, ship date, etc. Okay, so this is our OLAP cube which we are going to query with the help of MDX queries. Now let us start with a very simple query. Okay, so it is similar to a normal SQL queries, that is TSQL queries, in which we write select, but over there we have to specify the columns, right? Over here it is fine if we don't specify the columns, it will pick up the measure. Now select from our cube, this is SSAS Snowflake cube. So if we fire this, then it has picked up the first measure group sales amount. Okay, so if you want to verify, then we can verify it with the help of SSDT. So in SSDT let us put the sales amount. So you can see that this is exactly the same value as we have got in our SSMS, right? So these two values are exactly the same, which means when we are not specifying anything, we are just specifying a select from cube, then it's going to the first measure group and it's selecting the first, it's selecting the measure out of the first measure group, right? So now let's go to the second query. Let's understand hierarchy.children. Now in this query we are selecting measures dot total sales. So we are selecting this this calculated member on 0. 0 means columns, 1 means rows. Okay, so we are having on the columns we are having total sales, and due date dot hierarchy dot children, right? So we are having a hierarchy in due date and we are taking its children, that is we are taking these four values. So hierarchy has got multiple levels, out of it the first level is the year, and there are four distinct year values, right? So these are the four childrens. So we want on the rows we want these 4 years, and on the column we want total sales, right? Instead of 0 we could have easily said on columns, and instead of 1 we could have easily written on rows. This we'll see in the next query. So for this query let us see whether we are getting the same output as we expect, and we are getting the same output, that is on rows we are having year and on column we are having total sales, right? Now let's understand all members over here. So on columns we are having the same thing, that is total sales. Only thing is we have put a non-empty function over here. Non-empty function means, so if suppose a particular row or column has all values as null, then don't show that particular row or column. That's the meaning of non-empty. So we are putting non-empty on rows as well as columns, right? So firstly we are having total sales as part of the columns, and then we are going to dim product dot English product name, right, dot all members. All members means all the children. Okay, we can see over here, so these are the children, right? All children plus the auto calculated member all, all. Okay, this is a auto calculated member summary value. So all members will mean all plus all the children. Okay, so let's see whether we are getting the same output or not. So on rows we will get all the members along with the keyword all, that is a default auto calculated member, and on columns we will get total sales, right? So the same output we are getting. On columns we are having total sales, and on rows we are getting all members. Okay, but we can see that no value is null. That is because we have specified non-empty. What if we remove non-empty? Then we'll get all the members even if they are having null value, right? So see, adjustable race is null, bearing ball is having value null, blade is having value null, so they are all shown over here, right? So basically we are getting all member values from here. But if we put non-empty over here, then we will get all the member values which are not having nulls as the total sales value. So we can see all is present plus the first value is present, but this second value is also, this value is absent, right? The first member is absent, adjustable race is absent, correct? Similarly, blade is absent, correct? Ball bearing ball is absent, correct? Because these values are having null as the total sales. So non-empty means those member values display only those member values which do not have null in the resultant output columns or rows, right? Now default is all. Let us see these two queries are same. Okay, the previous query and the next query are exactly the same. These two are exactly same. Only difference is we have removed dot all. So we want to see if we are selecting total sales on columns and English product name on rows without dot all members, then what is the default output? The default output will be, instead of showing everything, it will show only this summary ALL all member. Okay, so it will show only one member which is ALL all, which is a summary value. That's the default output. Okay, so let's go and execute this query. Remember, in this query we do not have dot ALL return, right? So execute, and we can see we are having total sales on column and ALL all as the only member, the summary value in rows, right? Now let's go to the next query, selecting total sales for a particular product. Now we know these are the names of products, right? So what we will do is we will select the total sales on column as we have been doing in earlier queries also, but this time instead of all we want a particular product name. So what we are saying, what we are doing is we are going to the dim product, then English product name, this is the dimension, okay, this is the attribute, and inside the attribute we are having members, right? So what we are doing, we are putting a dot and ampersand, then we can write down the name of the member. So name of the member we are selecting is all purpose bike stand. Okay, so in this case we will get total sales is as column and only a single member called all purpose bike stand as part of the row, right? So let us execute this. So total sales as we are getting total sales as the column and only one member, that is this one, all purpose bike stand as the single row. Okay, so what if we let's see some of the rules now, how the query is getting executed, how it is identifying these members. Let's say we have written only this much, into square bracket we have written only the member name, then how will it identify? So it will first of all search all attributes of all dimensions, then it will check for all hierarchies of all dimensions, then it will check all dimensions, okay, and if it finds this particular member, that is thing that we have written in the square bracket, then if it finds the match, then it will output the result. Okay, so let's see example for that. Now in this particular next query we are specifying only the member name, right, in the square bracket, but we are doing two things. We are also putting a minus sign. So let us understand one by one. So on the column we are having the total sales as we have been doing in earlier queries. Now on the rows, that is on 1, axis 1, that is on the rows, we have put only one member name, that is all purpose bike stand, but with a minus sign. Minus sign means except. So we will get all the values, all members, all these children except the one that we have specified, that is except all purpose bike stand. So let us see if we are getting the output or not. So we are getting all children starting from adjustable race, right? we are putting all children except all purpose by extent. So the second value is missing, and it all remaining values are present from AWC logo cap. Okay, then all members are present. Okay, if you want to search, you can go through it. So which means we have displayed all children except the member that we have specified. Okay, now let's go to the next query. Select non-empty. Now in this case what we want is, we want to display value only for a particular member, that is ML road tire. Okay, so this is the member ML road tire. So we want internet sales of ML road tire only, right? But on rows, right? And on columns, what do we want? We want internet sales only for year 2010. So how have we specified that? So we have gone to this particular due date hierarchy. In that there is a hierarchy, right? And the first member is calendar year. Of this hierarchy, we can see first level is calendar year. Inside the calendar year, the members are 4 members, right? There are 4 members present, out of which we want to select only one member, that is 2010. So we have specified this member with dot and ampersand, right? So what we want on the column, we want sales value only for this 2010. So we want on the column header, we want only 2010 as to be written, and ML road tire is the product for which we want the sales. So let's see whether we are getting the same output or not. Execute. So ML road tire, and for 2010 we are getting the internet sales value. So it is exactly as we expected. Now let's go to the next query. Now these two queries are exactly the same. Only difference is, okay, is we have put dot parent over here. So we want to know that this is the member, but what is the parent of it? Okay, what value will we get if we specify dot parent, right? So on row we are sure we are going to get only one member, that is ML road tire. But for the sales value of this 1 year, as we are getting in previous query, we are getting sales value of only this 1 year, that is 2010. What if we put dot parent? Then the answer is, we will get the summary value, that is summation of all 4 years, which is stored in ALL all member, right? This is the summary member, right, which is auto calculated. So that will act as the parent for all these 4 year values. So which means we will get all, and the internet sale value, which is summation of all these 4 years, and the ML road tire in the row. So let's go and execute. Let's see we are getting the same output or not. And that's the output that we have got. That is ML road tire as row, and the summation of all 4 year values represented by the summary value of all, right? That is acting as the parent for the individual member of 2010 and other year values, right? So now let's go to the next. Hierarchy.children has only the first level children. So let's understand this concept. Over here we want on the rows, we want only the ML road tire. So this is the thing that we want. But on this particular column, what we want is due date.hierarchy.children. So due date.hierarchy is this one, dot children, meaning these 4 values. Now understand that there are multiple levels in this hierarchy, right? So year has got quarter, quarter has got month, month has got dates. So there are multiple levels of members, but when we are specifying hierarchy.children, at that time we will get data of only the first level children, that is year, that is 2008, 9, 10 and 11. So we should get 4 columns of 8, 9, 10 and 11, and on the rows we will get only one member, that is ML road tires. So let us see if we are getting the same output or not. So we have executed the query and we are getting the same output, that is on columns we are getting 4 year values, 2008, 2009, 2010 and 2011, and on the row we are getting ML road tire as the single product name, right? So this is exactly as per what we had expected. Now let us understand descendant function. Okay, so on the columns, on 0, that is on the columns, we are selecting descendants of due date to hierarchy. So this is our due date to hierarchy, right? So what we will get now, descendants will show all level members, that is all plus all first level children, right? And then it will go inside the hierarchy levels and it will show all the members of all levels, right? So when we execute this particular query, we will have to scroll horizontally because so many level members will be shown as columns, right? So let us execute. So we have executed this query and that's the output that we have got. That is, all is the first member, and then year, first year, and quarter, then month, then all the dates within that month. And we have to scroll horizontally to view all the data, right? So we are getting all the members, that is all years, all quarters, all months, and all dates inside those months, right? Now this display is not proper because scrolling horizontally to view data is not the usual practice. So generally we scroll vertically. So basically we want the same data but on with a vertical alignment. So what we'll do, we will put descendants or same thing but on the first axis, that is on the rows, and on the 0 axis, that is on the columns, we will put the total sales. Okay, so this let us execute this query. So we are getting total sales as part of columns, and on rows we are getting all the members, right? We are getting all the members because we have selected due date or hierarchy. So inside the hierarchy there are multiple level members like all years, all quarters, all months, and all dates, correct? So we are getting all the members. We can scroll over here, correct? Now let us understand the next concept, and it is subcube. So in MDX we can also create subcube. Okay, so this is the query. So what we are doing, we are selecting due date dot calendar year dot first calendar year, that is 2010, and the second calendar year, that is 2011 as part of the columns. And on the rows we are getting the default measure group measure, that is internet sales. Okay, first measure groups measure, that is internet sales. Now for this query, if we execute this statement, that is create subcube with a named cube and the query, then it will not show the output because it will create the subcube. Now it has created the subcube with the same name. If you carefully observe, this SSAS snowflake cube is the name that we have repeated. So now whenever SSAS needs to retrieve data which is there lying inside the subcube, which is matching with the subcube, then it will retrieve the data from the subcube instead of getting the data from the main original cube. So in the next query we will get the same data, that is due date or calendar year dot for the year 2010 from the subcube. Okay, so we are using the name of the subcube. So in this case the data will be retrieved for this particular year from the subcube. So remember, when the name of the subcube and the cube are same, and if the data is available in subcube, then the data will be retrieved from the subcube. Now let us see some more rules. Now we have been looking that we can represent a member in multiple ways, right? We can go by the whole hierarchy, that is dimension.hierarchy.attribute.member or dimension.attribute.member or dimension.hierarchy.member, right? Or only a member, right? Or attribute.member, hierarchy.member, or hierarchy.attribute.member. So these are the multiple ways in which we have been representing members, right? So in all these above notations, if member is missing, then the default all is given as output. So in everywhere, if the member is missing, then the default all at that level is given as the output. Now let us see the next rule, that is every MDX query should be submitted to SSAS server in its own batch. This is very important. In SQL and TSQL, we could have easily executed multiple queries as part of the same batch. But in MDX, every MDX query has to be submitted as part of its own batch, as separate batch. So if you want to execute two queries, then we can separate those two queries with the help of go keyword in between the queries, right? We will see an example for that in next few queries. For now let us go to the next query. That is, in this query let us understand two concepts, head function and order function. Head will give the topmost part of the resultant output. Okay, so over here we are specifying head with a value 4, which means we want the first 4 rows, correct? And order is similar to the order by clause of SQL and TSQL. That is, it will order the data. It will take 3 function arguments, right? So the order function takes 3 arguments. The first is what you want to show. So that is ship date dot calendar year dot children. So let's go to ship date, right? Ship date dot calendar year dot children. So what will be shown? This will be shown 8, 9, 10 and 11. These are the 4 children, right, for the calendar year. Now, based on what you want ordering to be done, so that is the second input parameter, that is measure dot reseller sales amount. So ordering has to be done based on the reseller sales amount. And in which order you want? In ascending order. And on columns, what we are getting instead of one measure. See, till now generally we are selecting one measure. Now we are selecting 2 measures, that is internet sales amount and internet sales count. This is internet sales amount and this is internet sales count. Sorry, reseller sales amount and reseller sales count. So these are the 2 measures that we are selecting with a comma in between. And out of these 2 measures, this first measure we are selecting for ordering. Okay, that is measures dot reseller sales amount is the one with the help of which we will do the ordering. So if we don't have any ordering, then default 2008, 9, 10 and 11 will be shown in the same sequence, right, in the increasing sequence. But if we are ordering and if the data of sales amount is such that the ordering needs to be changed, then this display will change. Let us see the output by running the query. So over here we can see that 2008, 9, 10 and 11 are shown, but they are not in a particular order, right? They are have been ordered based on the first column, which is reseller sales amount. So the first 2 years had null value, but the last year, that is 2011, had a smaller value as compared to the third year, that is 2010. So the year third, that is year 2010, has been shown as the 4th value. Okay, so first is 2008, 9, then 11 is shown and then 10 is shown. Why? Because that's the order of the increasing order of the reseller sales amount value. Okay, now tail. In this query, it is important to note that we are not using the ordering function. Okay, now in tail we want two rows as output. Okay, and we are selecting the same 2 things, that is reseller sales amount and reseller sales count as columns. So what will be shown? Instead of 8 and 9 will be skipped and 10 and 11 years should be shown, right? So let's see let's execute the query, and we are getting exactly the same output with the help of tail. That is, we are seeing the last 2 rows for year 2010 and 11, and we are seeing the 2 type of measures, that is reseller sales amount and reseller sales count. So now let's go to the next query. Members shows all and all members, right? So what if we provide only dot member? Then it has got the same output as dot all members, right? That is, it shows all the auto calculated summary member value and all the children, right? So let's see an example of it. So on columns we'll have total sales, and on rows we are going to have all the members shown by which order? By the order of total sales in the ascending order. Okay, so let's execute. So we can see that now all is shown as the first member, and out of these 2 members, what is the order which has been taken? The order which has been taken is as per the total sales, that is 2000 year value is smaller, so it is shown first, and 2010 value is greater, so it is shown afterwards. What if we want to break this order? See, all value is the highest value, right? So it ideally, if it is ordered as ASC, ascending order, then it should be shown last. But for all, it has got a special treatment. It always shows first, and then it orders the children based on the order that we have specified. What if we want to break this special treatment for all, and we want to break the hierarchy? Why it is showing all as the first value? Because for these 2 values of children, that is 2010 and 11, all is the parent. So it is showing parent as first, and then it's showing his children. So what if we want to break this hierarchy? Then we put a B over here. Okay, and then execute. So we can see the lowest value of 2011 is shown first, then the higher value of 2010, and then the summary value, summation value of these 2 years is always greater, and it is shown as the last. So we have broken the hierarchy, right? So if you want to maintain the hierarchy, just write ASC or DESC, and if you want to break the hierarchy, then just put a B in front of it, that is BASC or BDESC, okay, for the descending order. So over here we are having all and all members, that is it shows the children as well as all, and now it is showing as per the order that we have specified. So now let's go to the next query. Let's go to children show all members without all. So this we have seen earlier also, right? So whenever we specify children, it shows all the children and it does not show the auto calculated member all. Okay, so in this case we want to see total sales and reseller sales amount as the two measures, and on rows we want to order based on the total sales in ascending order, but we want to see only the children. We do not want to see ALL all written, right? So we can see out of the 3 rows, this time only 2 rows are shown and the row for ALL all is not shown. Okay, now let's go to the next query. Using star for permutation and combination of members, right? If you carefully observe over here, now let's say we drag and drop multiple things. Let's say we drag and drop product name, right? And then let's say we go to customer and we drag and drop gender. See what we are doing now, because there are 2 values for gender, male and female, right? So that's why this product is now appearing for 2 times. Basically all purpose bike stand is now have started appearing 2 times, one for female and one for male. So basically we are doing a Cartesian product, that is we are trying to find out all the permutation and combinations, right? In the same way, if you put marital status over here, then it will have 4 values, correct? All purpose bike stand is now having 4 values. 2 are for female, 2 are for male, and out of the 2 rows for female, 1 is for married, other is for single. Similarly, out of the 2 rows for male, 1 is for married, other is for single. So there were 4 total possible combinations, that is permutation combinations possible for bike stand, all purpose bike stand, and all 4 are shown. So this means when we are dragging this particular dimension members over here, it is actually doing a Cartesian product. It is actually doing a permutation and combinations. So what if we want to do the same in MDX query in the return syntax? Then we can make use of star. Okay, so let us see an example of it. So on the columns we want the same 2 measures, that is in total sales and reseller sales amount. But on the rows we want Cartesian product between children of due date dot calendar year, so which means these are the 4 values, correct? Due date dot calendar year, so this is due date and this is the calendar year, and it has got 4 members, 2008 to 2011, that is 4 year values, into due date dot calendar quarter. So basically if you go to calendar quarter, then it can have again 4 distinct values, right? 1, 2, 3 and 4, but these values are coming as per the calendar year. Okay, so basically what we want year and then its quarters and these 2 major groups, then the next year, then its quarters and the values for the major groups, right? So let us execute and let us see if we are getting the same output or not. So let us execute. So that's the output that we have got, right? So we are getting years, its quarters, combination of years and quarters, and what we are getting is the total sales and reseller sales amount for it. Okay, now 3 levels of permutation combinations and correct way of writing that query. Now over here we had 1 star, which means we had 2 levels of permutation and combinations. If we have 3 levels, we will put another star, right? So in this case we have 3 levels of permutation and combinations, but the query in such a query should be written properly in well formatted manner, so that its readability increases and people who are reading that query can understand that query better, right? So this is the way in which we write, that is, we separate all these permutation combination values in separate rows in the query. So this is a better way of writing the query instead of putting everything in a single row, right? So what we are doing, we are having 3 levels of permutation combinations as rows, and on the column we are having the same two measure groups, that is total sales and reseller sales amount. So let's see the output. So this time we are having three permutation combination values based on year, based on quarter, and based on the month name, right? English month name. And then we are having corresponding total sales and to reseller sales amount. Now now over here all the data is shown. What if we want to introduce a where clause? What if we want to filter, right? So what if we want to put a where clause and we want to filter the data based on a member? So let us see, we are having the same query up to here, but over here we have put a where clause and we are slicing the cube based on female gender, that is data of only female customers, right? So what we have done, we have gone to the dim customers. Over there is gender attribute. In gender we are taking only this particular member, right? So it will give the sale values, that is measure group values, summation values based on only the female data for the sales, that is total sales and reseller sales amount only for the female customers. Now so we have used two things, where clause and we have created a slice of the cube with the help of ampersand member. Okay, now let us go through some more rules. Dimension cannot be repeated across the axis, so you cannot have same dimension appearing on axis 0 and axis 1, right? Actually there can be total 125 different axes which are numbered from 0 to 124. Okay, out of this 125 axes, the first 5 axes have got unique distinct written names. So the first axis is called columns, second is called rows, third is called pages, fourth axis is called sections, and fifth axis is called chapters. So instead of writing 0, 1, 2, 3, 4, you can actually write the names of those particular axes up to 5 axis levels. After that you will have to refer those axes with the help of their numbers, that is axis into bracket 0 or axis into bracket 1, similarly axis into bracket up to 124. Okay, so now dimensions cannot be repeated across the axis, so no two axes can have the same dimension. Also dimension used in axis cannot be there in the where clause. So over here in the where clause we have taken different dimension, right? We are slicing the cube based on customer dimension as customer is not present on the axis, right? Every MDX query should be in its own batch that we already seen. MDX treats every time member based or as a keyword. This we'll see in the next query. MDX treats every measure as a dimension. Okay, this is important and good to understand, right? So MDX treats every measure as a dimension. So for MDX query, even this measure is a dimension. So can you see in the tooltip, it is showing measures as a dimension, right? So now only one rule we have to discuss, that is MDX treats every time based member as a keyword. This means this ampersand f is not a time based member, right? So we could have easily written only f and it will still give us the data, same data. See, so it's fine if we don't write ampersand, but same is not true when we are dealing with the members of the date time hierarchy. That is, if this is 2010, then I cannot remove the square bracket and ampersand. Okay, if I remove both things, that is square bracket and ampersand, then it will not work if it is value 2010, that is if it is a date time member. Okay, now let us save everything. So now let us see some more examples where without ampersand for members and looking at data, two different queries with the go statement. Now we are having the same cube query as in the earlier example with 3 levels of permutation combinations. But in first query, we are slicing for the data of female customers, and in the second query, we are slicing for the data of male customers. And importantly, see, we have omitted ampersand. Okay, still it will give us the output. Now, as we had discussed that rule that if you want to fire 2 MDX queries, we have to separate those 2 queries with the go keyword, and that's what we are doing. So we will get output in we will get the output of 2 different queries. So let us execute. So now we can see that we have got output of 2 different queries, and each is a separate scrollable area in the output pane. Okay, so in this way we can get the output of 2 queries with the help of go separator. Okay, batch separator. Now, what if instead of writing this fully qualified member name, that is M is the name of the member, right? So what if we, instead of writing the fully qualified name, we just write M? Will it give output? Yes, it will give the output. Why? Because it will still be able to find this member M in the hierarchy tree, right? Hierarchy member tree, dimension attribute member tree, correct? So this is the same query. Up to here is the same query as we have been using in earlier queries. Only thing is we are putting only M after where, and it should give us the data, right? So we have got the data. Now the only problem with this query is it is creating ambiguity. Why? Because M is present as gender M, that is representing male as a gender, and for marital status also there is M for married. So now it becomes unclear which M we are referring over here, right? So that's why this query gives ambiguity. So it is better to write the member name in a fully qualified way. That is, instead of writing just M, we should write dimension dot attribute dot member name. Okay, so this is a better way of writing the query, right? Now let us write member name without square bracket and see what happens, right? So in this example query, we are having total sales. We are selecting total sales on the column. Also on the row, right, we are having gender dot members, but in the where clause we are putting dot 2010. Now this is incorrect, right, because this will act as a keyword. Okay, this is a date time dimension member value, so it will act as a keyword. So this you cannot do. See, right? So this is incorrect. Now same value you can write but with a square bracket, then it will treat it as a member. So this is the same query. The only difference with the previous query is we have just put the square brackets, right? So let us execute this query. This will give the output, because then it will search for this member name 2010, and it has found the member name for year 2010, and it is giving us the data, okay, for both the genders, that is male and female, along with the all default summary value. Now let us see some more examples. Let us see the top count function. Top count means we are having the first 10 rows. So there are multiple English product names, but out of which we will select only the first 10 members. So we can see only 10 members have been selected, and that too the first 10 in the alphabetical order. What if we want to select the last 10 members in the alphabetical order? Then we can write the bottom count as a function name. So it has selected last 10 members from the alphabetical order, right? Also filter. This is very, very important for MDX. How do we filter, right? So because see, with the help of where clause, we were not filtering the data. We were only slicing the cube. Okay. So we were not putting any such clause like this total sales value greater than 8,000 or something like this, right? We were never filtering the data. We were only slicing the cube. So what if you want to filter the data in the MDX? Then we have got the filter function. As we had the order function, similarly we have the filter function. So over here we want, on the columns we want total sales, and on the rows we want children of English product name. That is, we want to display all the product names, right? So this is a simple query, just an example default query. Now we can see that there are many member values which are having sales amount greater than 80,000 and less than 80,000. Okay, so we are having many such values, right, for which the sales amount is either greater than 80,000 or less than 80,000. So what if we want to get only the filtered data, that is we want to get member values which are only greater than 80,000? Then we cannot write a variclause with that, because this is MDX, this is not SQL TSQL. Over there we can specify the variclause, the filtering part in the variclause with the help as part of the equation in the variclause. But over here we cannot do it. We can only slice the members of the cube with the help of variclause. Now for filtering, what we can do is we can write the filter function. Then we have to, it has got multiple arguments. Now the first argument is what we want to show. So we want to show all English product names, that is all children. But out of which, what do we want to filter? We want to filter these English product names based on total sales value, and we want the total sales value to be greater than 80,000. So this column value should be greater than 80,000. Then only we want the row to be displayed. And so let us query this, execute this query, and we will get exactly the same output. That is, now we are getting English product names on the rows, but we are getting only those English product names for which the sales is greater than 80,000, and that's what we have specified in the query. Okay, so now we have already discussed that axes are total 125 axes and can be named as axis 0, axis 1 up to axis 124. So let's see an example of it. And the first 5 axes have got a unique named values, that is column, rows, pages, sections and chapters. So these are the names of the first 5 axes, right? So now let us change the naming convention over here. Now we'll, instead of writing columns, we will write axis into bracket 0, and instead of writing rows, we will write axis into bracket 1. And let us execute it, and we can see that we are still getting the output, right? So this is also an alternate way of specifying the names of the axis. We can specify as axis 0 and axis 1, right? Now with member, what if we want to do some calculation, right? In SQL we can say that column 1 comma column 1 plus 500, let's say, if it's a numeric column. Over here we cannot do this. So we cannot have runtime calculations in MDX. So if you want to achieve it, how can we achieve, right? So see this example. This is not possible. We cannot say measure total sales plus 1000. We cannot get this value. It will give an error. But what if we want to achieve this? We want the output of total sales plus 1000. Then we can achieve this with the help of with member. So we'll have to define a new calculated member runtime in the MDX. That is, with member we are specifying a runtime member measures.projected sales as our calculation value, that is total sales plus 1000. Now we have in our MDX we have a runtime member which is projected sales with the required formula, and it has been defined. So now in our query we can use measures.projected sales as one of the measures, and it will get this auto calculated values, and we will have total sales also. So let us execute this query. So remember, there are two parts. One is with member, we are specifying the calculation, and then in the query select statement we are using that calculated member, and we can see over here we are getting the output, that is wherever there is null there is plus 1000, there is 1000 value. For all other values 1000 is added from the total sales, let's say 37,000 something, so it is now 38,000 something, right? It is 6,000 something, so it is now 7,000 and something, right? So which means 1000 has been added to the total sales amount for the projected sales value. Now let us see one more query to understand use of current member dot previous member. Now we will use with member yearly performance as total current sales minus the sales of the previous year for the same time period, that is total sales in now this, whenever we are writing in this value, that is in brackets with a comma, then what we want is, we want the first value under the context of the second, right? So with this comma, we are specifying that we want the total sales value. But how do we want this total sales value? We want under the context of this thing, that is due date dot calendar year dot current member is the current calendar year dot previous member, which means the previous calendar year. So if current year is 2011, then this means total sales for 2010. Okay, so this whole thing will give, let's say if the current year is 2011, then this whole selected value will give the total sales for 2010, that is the previous year. This we will subtract from the current sales of the current year, that is total sales for 2011. So this will give the yearly performance. Okay, so let us execute this query and see its output. See, we are having 2 years on axis 1, right? We are having 2 years, and see the total sales, right? So total sales is for 2010 is 2010 minus 2009, and for 2011 it is 2011 minus 2010. So this subtraction as 26 minus 41 will give around minus 15. See, so this is the output that we are getting, right? So the important thing to understand in this query was the use of current member dot previous member to find out the corresponding value from the previous member, right? Okay, and that too using this notation, that is separating with a comma and specifying the context for this value with the help of the second part after comma, right? Now let us see union clause. So for the union clause, it is same as the union clause in our SQL TSQL, that is, but it will combine the data of two queries. But over here we have union as the function, right? So we can use union in either column or rows or any of the axes. So in this example, we have total sales on the columns, and on the rows we are having union, right? Of what? Of two products, all purpose bike stand and cable locks. So we should get only two rows, one for all purpose bike stand and another for cable locks, right? So let us execute this query. So we are having two rows, first for all purpose bike stand and second for cable locks, and its total sales, right? Now except mean every member except the one which we have specified. So over here in the columns we will have total sales, but on the rows we will have all children of English product names. Okay, so let's go to English product names, right? So we will have all children of English product names except all purpose bike stand, right? So let us execute. So we can see that first member name is present, second member name is not present because we have specified in the except clause, right? So second is not present, but from the third member onwards all members are present. Okay, so in this way we can use the except function. And our last example for intersect. So intersect will find the intersection set. So if we intersect all children, that is all members, with a particular member, that is only one member, all purpose bike stand, then what will be the intersection set? It will be the single all purpose bike stand. It will be a single row, right? The intersection will be a single row, that is all members, intersection with one member produces only one member. So let us see this sample query just for understanding the way intersect treats the data, right? So let us execute. So we can see all purpose bike stand as the only row coming out due to the intersect clause. Now we can use we can see at one last query, one more query, right? In this it is same as the previous one, intersect, but we are using union to have intersection of two rows with the whole set, right? So which means in union we are selecting two rows, all purpose bike stand and cable locks, and these two rows will intersect with the all children. So we should get only two rows as the output. And let us see if we are getting the same output when we execute the query or not as per our expectation. And we are getting the same output as per our expectations, that is we are getting two rows, one for all purpose bike stand and another for cable locks, and on the columns we have total sales, right? So I hope friends this video tutorial on MDX queries is useful to you. Thank you.